Alrighty. On the left-hand side here is a link that you can scan or type in the link. It doesn't look very interesting at the moment. I'm just going to slow reveal links that we're going to be using. When Anna first came to say if I'd like to present at the plenary session, I said, well, what's the theme? And the theme was technology, and then there was also possibly and probably thrown in there as well. So hopefully some of what I do today is related to that theme. Just a little bit about myself before I start. So one of my colleagues refers to me as that guy, Infinity Plus 2. Possibly because I have a YouTube channel as well, although it's not as well received. That's how my students refer to me as in cupcake form, which is fairly accurate. That's why I had a haircut last night so I could match it. I've got a long connection with Mount Albert Grammar because that's where I've taught for my 12 years of teaching, but also with Dilworth School. As I said in the blurb, I went to Dilworth as a student from the age of 10 right through, and then I also was on staff for 15 years, and I've just finished up at the end of last year in the boarding side of things. So that was a game of football played between my Dilworth side that I was coaching and a whole bunch of MAG students that I had taught. That was the only selection criteria. They couldn't be in first 11 and I had to have taught them. So it was an awesome little game that we had last year. I'm actually originally from Tauranga. That's me up the top of the mount. I try to do that once every maybe 5 or 6 years. I'd like to thank the boss, Mr. Drum, here for letting me come to speak to you today. I don't know why he lets me do all this because I'm not exactly the nicest to him or his deputy. I've known to photobomb his media opportunities with my car. I've beat him in a 100-metre race. I've also played cricket with the guy on the left-hand side there. Is me and him opening the batting. I've long associated with cricket, so if there's any errors in my slides, it's because I was watching the Ashes last night as I was finalising them. I've been in the staff band on the drums. That's our winning quiz team from this year. I wanted to put that on the website, but Anna said I needed a more formal picture. But 4 of those students are in my stats class, who were in my stats class this year. Organised CalCX at MAGS this year. Someone asked if I could do a StatsX version. I'll have to think about it. And then, of course, I've had the pleasure of teaching some amazing students over the last little while, some of which presented last year at Maths Day for me, which was really, really humbling. So I guess, whilst that's a background of who I am, I feel like you're probably here to hear a bit about what I do in the classroom with my students. And so, as you can see, I'm looking quite inquisitive there. This was last year's lot. This boy here got outstanding scholarship in stats 2 years in a row, and this boy here also got scholarship in stats. And this was a highlight of my last year's teaching. So, it was, for some context, it was dry Weet-Bix, a dry Weet-Bix challenge. Well, we initially flipped the coin, and half the class got a bit of milk to go with it, and half the class were doing the Weet-Bix bites dry. And then these two were just, they were absolutely amazing at it. So I said, we had some Weet-Bix left over. I said, okay, well, let's challenge you to it. You probably didn't hear in the recording there, but I said I should do this every lesson because it keeps them quiet. These two boys were the most outspoken, and it was the quietest I'd heard them in all my time teaching them. So that, whilst that's a practical lesson, I'm going to focus more on the technology side of things. So when I was preparing this, I just went through an absolute mess of a computer. I went through and found, I'm calling it the top 10 list, but it's things that I've actually used this year in my teaching, and some I've used for many years prior to that. And I figured we would run it maybe like a little bit of a competition. So I've got some chocolates. I was told I've already opened them. I've sampled them. So as I released the list of the top 10, and please don't argue with it because I did have trouble ranking it. We're going to have some time to play around with each for like a couple minutes only to speed through. But I'm going to put up as an example some honourable mentions. Obviously, these 3 get a good run. This website's great. This website's awesome. This website's pretty good, this website's great, links will come later, but they didn't make the top 10. So when I put up this, which this one's should be a familiar one, first person to name what it is gets the chocolate. Pachinko game, nailed it. I did an awfully needy one first. There you go. So, okay, that one's an easy one, but that's the pachinkogram. So, in terms of using the pachinkogram, if you're on there, hopefully this will work nicely. Oopsies, I just showed you the next one. If I've done this right, pachinkogram should go there. Alright, so can I just have a show of hands who's used this in their teaching of probability? Because it's been around for a little while now, and actually, to be honest, none of the stuff that I'm sharing today is brand new, hot off the press stuff like the curriculum released sort of thing and the names of the subjects and whatnot. So the pachinkogram is used for conditional probability. A typical example of it would be like a false positive situation. So you've got 1% of athletes there at the Olympic Games are drug cheats, and then you're doing a test to determine if they are a cheat or not. And so when we go to this pachinkogram, we can put in the levels. The first level is labelled diabetic currently, which maybe some of you in the front row after this talk. But if we go and we change the label to whether the person's a cheat or not, so 1% of people are cheats, this is a great visual way of visual representation of what's happening with the conditions. And then down here, 98% of them are going to test positive. It's quite sensitive sometimes with the screen, so I can only get it to 99 in my rush. Then these people, the healthy people, they're the non-drug users, the bulk majority of people, and then the other way around, most of them are going to test negative with the occasional testing positive. So you set that up, you sample it through, it sends 1,000 athletes through this simulation. It shows you that very few get through to the positive level. Most people go to the right, and then most of the people on the right end up on the far right. But down here, what you can do is you can work out how many people have ended up in these boxes, and you can do some conditional probability over here. Because if I give this question to most Year 13 students, they would go with the person's a cheat, right? 98% sounds like an accurate test. So if they've tested positive, they've done it, right? But then you've also got to weigh up the fact that most people are not cheats. So yeah, I use that quite a bit. Level 2, level 3 probability to teach conditional probability and what we call reverse conditional probability. Okay, second one. Number 9, we're going backwards. Anyone recognise that? Yes. Oh, nailed it. Look at that, told you. Yeah. No more university people. So this is called Allocate Monster. So it's one of Anna Ferguson's tools. It's a very simple tool, but it's really, really useful if you're teaching experiments. So if you go back to your document there, I'm just going to paste in the next one. I want you to go to the link on the right-hand side, which says, "Would you interview this candidate?" I'm going to give you a minute. Can you just click it? "Would you interview this candidate?" You'll see that there's a CV attached that you can have a read of. Imagine that you're making decisions. Maybe you're Dave down at Lincoln, and he's getting a flood of CVs after today's workshops. Have a read of the CV, and then just vote on whether you would call up the person for an interview based on their CV. Is the link working for people? Okay, you got 30 more seconds to make a decision. All the flood of interviews potential that we get as maths teachers, so many of them. You have to make quick decisions. Usually I would do this in a more controlled environment so you couldn't talk to your neighbour, because I guess that's the main issue of it, right? Allocate Monster, the way that it works is you feed it some links, literally, feed them survey links, and then it will randomly redirect you to one of the forms. So I don't know if you realised, but you're stats teachers, so you probably know the game I'm playing. But there were 3 links, so there were 3 different surveys, 3 different CVs. So if I load this up, how good is this candidate, and I click on the CV, it takes me to a guy called Sunny Dharma, who is a friend of mine teaching at Waiuku College. I told him that I was using his name for this purpose. There are two other CVs in there. There's Steve and there's Tanya. Now, I've used names that you guys are probably familiar with, but to students, they are not. And then everything else about the CV is the same. And because of the disguise of them not knowing that there was multiple different CVs, we've just run a really, really simple experiment. Of course, at the end, when I told them that there were 3 CVs, it was very quiet in the class and a little bit awkward because they were like, oh crap, how have I made my decision on whether I would interview this candidate? Have I literally made a decision based on a name? And, you can talk about the ethics of that sort of stuff, but really easy to use, allocate monster. Alrighty, number 8. Another Auckland University one that was presented a few years ago and is on the Census at School website. Any names?
We got nothing.
You got nothing? Oh, okay, going once, going twice. Chocolate to me. It's called Scampi. It's just a strange name for it. I think there's a justification as to why it's called that. Let me just load that one up for you. This one, I tried this out for the first time this year in my class to teach the Poisson distribution. Apologies, a lot of my talk is directed at senior statistics. And so, when you go to the Scampi website, it's already got some data in there, arrival time data, but personally, because there's no context here, I don't use that as my example. What I prefer to do is switch from the data mode to video mode, and then you can put a YouTube video link in there. I have put my own YouTube videos in there. I used Anna Ferguson's for inspiration. She'd done one where she counted the number of ums and ahs in her videos. But you could go as simple as going New York ambience sounds. So if I copy this and where is my Scampi? Chuck it into here. Hopefully it all works. And you play it. When I hear car horns, it helps if I click start. Bit of bad language in it. I think it's allowed. Anyway, if you just make up some data. I didn't tell my students they have to go to New York ambient sounds or listening to birds in the bush or whatever. But some of them did some crazy things, like they were watching fights and they were counting the number of connections. Or one girl was cracking up at the back of the class, and it turned out she loaded up some influential person that was really good at burping, and she had a whole bottle of Sprite, and she was literally beeping every time the person burped. And then we had a great discussion of whether the burps were random and independent of each other. It was oh, there we go. Someone's found the button. So anyways, the cool thing about this is it's all animated and visual. When you count an event, it records it as an arrival. When you play back, like I obviously made it up, so I got absolutely nothing. But you can split your time intervals. So no events in 4 seconds, no events in 4 seconds. I got 10 events in that 4 seconds. Then you can move it on to looking at the number of counts, which is basically leading you towards determining if a Poisson distribution is suitable. So you can trial it out with actual real stuff, like, for example, the school bell goes and students, because they're all coming from wide areas of the campus, they drip feed in. So I was beeping the thing as they were walking in the classroom. They thought I was strange, but they're used to me. You could also challenge that, because if students are coming from one class, like physics, into statistics, then they're coming as a bulk group. But yeah, that's how I introduce time-related distributions for Poisson. Okay, number 7. Feels like Skittles and Feed the Rainbow. Anyone used this one before? Recognise it? this is kind of cool because you're learning new stuff. I thought I was just showing you some old stuff that had been around a while, but I'm not doing well in giving up the chocolate. So, okay, this is called rock and pole graphics, and it's what I use to teach stuff to do with surveys and margins of error, and you know, things like political polls, like when there's an article that's written about these guys and it says Labour surges ahead, and then it's based on a plus 1% kind of movement. So, you know, the media don't necessarily know how to interpret the polls they're reporting about. Okay, so rock and pole graphics is about a fictional land called Poland. So they really thought about that, eh? And in Poland, you know everyone's political preference. So unlike when you're surveying or doing an inference, you don't know what the population's all about and you're trying to estimate it. But in this case, you do know the population. It's using it as an example or a toy example. And then it just steps you through the process of, showing their preferences, sorting them into groups. It's very visually appealing. I guess we're in the arts building, so it's quite good. And then you can see, like in Poland, the Red Party is the most favoured there, with 31% of the vote. And then it takes you through, like, what would you do if you wanted to estimate that? Well, of course, you could poll one person. And all I'm doing is just clicking stuff on the left-hand side. You survey one person, you get it completely wrong. You survey another person, you're still completely wrong, and it just takes you through that process. There's a lazy button. This is where it's really satisfying. It's like lollies falling from the sky. It shows you that there's big errors, as you would expect when you only ask 10 people. But something about students, they think that 30 is the magical sample size. And I noticed that the new curriculum at the junior level, they've now specified 1,000 for categorical data, because there's so many surveys that are based at school level which are based on a classroom size of 30, roughly, and then they think that their answers are like the gold standard. So even with like 100 surveyed, there's still big errors, and it settles down a little bit when you get to 1,000. So yeah, Poland, or rock and pole graphics. If you're teaching the 1/(n) formula for seniors, or even if you're just teaching juniors, you want them to understand what happens when you survey. And then one last thing is that you can show multiple polls at once. To show that the parties that are closer to 50% have the biggest errors associated to their estimates in general. Whereas the minor parties, whilst the poll might say 3% margin of error, the minor parties don't have a 3% error to factor in. So yeah, I think that's a really visual way of describing a margin of error formula. Number 6 is a blog. Is this blog familiar to you? I actually stumbled across this blog from a calculus side of things, because the person who wrote this, who's actually passed away a few years ago, so there's no longer blog updates, but there's a whole bunch of really nerdy stuff on it that you can get easily stuck in a rabbit hole. Anyone know the name of it? It's called Data Genetics. So the word data's in there, so stats teachers, yes. So yeah, Data Genetics blog. I've just pulled out 3 because I guess with like anything, you know, if you're given a million resources and stuff, you might not use them. So if I narrow it down to a few, you might actually try these things out. But like Dave said this morning, I think like there's material out there, but you have to actually put the source to it. So yeah, pin number analysis is a really neat one, which I've done in my class, where I've asked them to actually write a list of fake numbers. You might have done a similar thing with like fake coin flips. You ask them to write a series of numbers. Imagine that you've hacked a phone and you've found a list of passwords and and you get them to write them down, and then we as a class decide on is it a fake list or is it actually legitimate. And so this person's done this. He does put a disclaimer in here that it's not to help people actually hack, but if you skim through it's some really good questions in here, like what is the least common PIN number? What is the most common PIN number? And surprisingly, it's 1, 2, 3, 4. And then I reflected on my iPad login, which is 1, 2, 3, 4, 5, 6. But yeah, he's got the whole frequencies of all the pin numbers, and so like 10% of these pin numbers that he found in this list were 1, 2, 3, 4, which is pretty crazy. And then 6% further were 1, 1, 1, 1. And then the reason why I really like this blog is because the person just takes it to the next level. Like you've probably all got these students in your class who are just like, if you pique their interest, they'll want to go off and explore it further. And so I really like the visual down here, which shows that in the top sort of most frequent pin numbers, all of the numbers starting with 19 appear. I think maybe why that is. And then also down here, this sort of diagonal of pin numbers appearing. All the numbers 4444, 5555, and all that. So yeah, I think it's just a really neat visual. Like it's a heat map showing you where the most common passwords are. The other two that I linked in there, the Price is Right is a probability-based one. If you remember this, the wheel that gets spun and you have to make 100 cents. There's a link in this blog which shows you about this, like a three-way tie between three people. They all get $1, and then they re-spin it and they all get $1 again. It's crazy and it's so unlikely to happen. And so the guy goes and explores the chance of it actually occurring, and also strategy-wise. And then birthday paradox, if you're familiar with that, he just takes the birthday paradox to the next level. Oopsies, why is that not working? Because if you've ever done the birthday paradox in your class, it's quite nice to go around and introduce yourself and say, hey, my birthday is July 26th. Anyone else? Yeah. Blake and I went to university, so actually I knew that fact already. Oh, look at that. Got my trigonometry right as well. Clearly I was taught that in year 10. So yeah, it takes it to the next level with the maths, but then also goes and says, well, what happens if we feed real data into it where birthdays are not equally likely? Because that is the question, like the September babies that were born because of their parents' decisions at New Year's, and yeah. So I honestly, this is like a whole lesson in one where you just focus on the birthday paradox. But the blog gives you sort of things to explore with the most keen students as well, or make you look like an expert if the maths is a bit hard. Yeah, so that's number 6. Number 5, surely. I heard it. The islands? Did I hear the islands?
But you almost showed it to us.
Oh, did I? Yeah. Who wants the chocolate? Yeah, so the islands, did I almost... Oh, my bad. Oh, no. I've been fooled by... Okay, so the islands, now this one here, you need a login for it, and I'm pretty sure the guy still is around to get one. So you just Google the islands, it brings you to this website. Try and hide my thing. I've got a login for it. Personally, I just give all my, if my teachers are keen to use it, I just give them my login. I'm not worried about that. Possibly shouldn't give my login to everyone here though. But you might want to guess the password. It involves a 1, 2, 3. Who's used this before? This has been around for a while. I think you shared this to me, gosh, about 6 years ago now. And
more like 16.
Oh my goodness. No. I've only been teaching 12.
Probably 10.
Yeah. So look, I've used this every year successfully, and it takes a different twist every single time. The idea with the islands is that you can go in and experiment on islanders. You've got ways of randomizing things. You can phone them up, random digit dialing. It still exists in here. Or you can just be lazy like me and just click a random house, and hopefully the person's awake, because I tested last night and they were asleep and not responding. So it turns out you can't obtain for consent if they're asleep. Tasks. So you can go in there and you have to ask them a question about whether they actually want to... Oh, come on, Lynn. You... I'll go to the neighbour. Hey. Now, recent tasks. If you do this with your students, you can untick tasks if you're not happy with them doing it. There are ones and the students always go there, the senior classes always want to give 10 shots of vodka to a baby and then make them run 100 metres. So we can go into different tasks here. So like I can give them an alcoholic drink if I want. Like I said, you can turn these off if you don't like them. I can give them some light beer. The thing about this is you get a real appreciation for data collection because you have to wait for them to do the task. And students get really frustrated with that. Go, I want to know the answer now. And then once they've drunk the beer, you can make them run or do a reaction test or something like that. And this is actually used at university over in Australia with their med students. So if you need any inspiration into how to use it, there's a couple of secret little islands here. Number one, this island here, which students don't know about and probably don't click it, is actually where you set up your classes. So I've got my class in here. You can go in and you can see how many times they use the chat function and ask Islanders questions. Some students, it's almost like they find a friend in these people. And then there's another one with the Academy, and the Academy in here actually shows you different reports that have been done by university students, which have used the islands to collect the data. I showed that to a Year 12 stats class a couple of years ago, and my investigations went into way more depth than they used to be. I had one girl that was looking at whether islanders that had a pet were happier. And they asked them a survey about their happiness. They also know whether they've got a pet or not. You can look at the gender pay gap if you want. There's a whole bunch of stuff you can do. And just to show you one last function is when you're in the context thing, they do die. So, as you can tell, I've used this a lot. They do die. They don't die like in our human years. The calendar's a bit different. But you can ask the questions of the ghost if you want. But you can see, I've asked. That was a question that I asked for the gender pay gap kind of idea. But you run into a few issues. Like if you ask them how much they earn per hour, $32 a day, but they don't tell you how many hours they work. So then you actually have to ask them that. Currently unable to chat because, yeah. Anyways, that's the islands. If you want to sign up to that and you want some information about it, feel free to email me. But the main guy is contactable just find him on Google, I'm pretty sure. He would love to sign you up for a teacher account. Okay, number 4. Oh, sorry, that's another investigation I did. Ages when males first started smoking compared to when females first started smoking, of the smokers that live on the islands. Anyone done this one before? It's kind of similar to the whole fool the teacher thing, where you flip some coins and you try and guess if they're real or fake. I tried to make them harder, right? So the number four, I wasn't expecting anyone to guess this. Catch the Cheaters website. I was shown this by a student actually, and it's a good one to play around with. So if you go to the link, we will I'll give you a few minutes to play around with this and see what you think. The less flips you need to make a decision, the more points you get. But as you know, if you flip 2 coins and you get 1 head and 1 tail, you can't determine if it's a fair coin or not. Some of them are coins that are biased, and you've got to work out which ones they are. I'm going to struggle to get you back now, but so that's that game. It's good fun because you can. We live in a cashless society. Getting coins out of people's pockets is kind of hard, but that's quite a fun game. The other thing here, this coin flip test. So I don't know. Earlier in the year, you might have seen a post from me on the Stats Teacher Facebook page. Good times on that page. And about Google Sheets and how the random number generation on there wasn't doing what it should be doing, and it was based on a question that I asked in class, which we knew the theoretical answer to, but it wasn't doing what it should be doing. So just to quickly summarise the spreadsheet and what it is, we're flipping 5 coins in a row. The coding here is not mine; it's actually a student who was really into Python and so did it for me. 5 coins in a row, and then the question is, what's the chance that you get at least 3 of the same kind in a row in a block of 5? So you can see in here, heads, tails, tails. There wasn't a sequence of 3 that were the same, whereas in this one here, heads occurred, so that's a pass. So 3, 4, or 5 in a row constitutes that. Now the answers here, surprisingly, because this is months since I did this, are actually now in line with what it should be. It's about 50. The answer's 50%, and the simulation here is showing around 50%. The I'm lost / me too was the student working in their English class the period after my stats class. It's always, it's a good problem when they're still working on it instead of doing what they should be doing. And me too is me replying to them in my free period because what they were doing is testing out the code, and what we found at the time was that if you get Google Sheets to flip 100 coins, and then you get them to flip another 100 coins in the second column, there was some sort of dependency between the coin flips, which was really crazy. But if you looked at the overall coins, you got around 50%. But if you looked at like the matching, you'd expect about 25% would be two heads, 25% two tails, and 50% one of each. And it wasn't. It was something ridiculous like 60 to 70%. It was not sampling variation. Having said that, whatever's Google's done, they've fixed it, because I was going to use this as an example of why Google Sheets shouldn't be trusted. But it's doing the right thing now. So they went off on a massive tangent of checking their maths, doing binomial stuff, and then they found some algorithm around random numbers off Wikipedia. And that was doing a better job at the time than Google Sheets was, which they were quite proud about. So anyways, a simple coin question can lead to like real complicated investigations. And just, if you've got students that are into that, just let them go. Let them play. Okay, number 3. Surely. Oh, that one that comes up in exams with the grey cloud. But what's it called?
It's Anna Ferguson's tool.
Who said that? Yeah. Unfortunately, Anna had to go home before the session. But, she would be proud. Oh, sorry, mate. I was proud of that throw. So, Anna Ferguson's modelling tool is absolutely amazing if you know how to use it. If you don't, it can be a little bit of a maze to navigate. So, if you Google modelling tool, if you just wait one sec, I'll give you the link. I've used this in class mainly for distributions teaching, but to basically explore when things seem unusual. Like, it's kind of a similar vibe to the catch the cheaters thing. If you flipped 10 coins in a row and it was a fair coin, you wouldn't expect necessarily 50-50, but would you be surprised if you got one head and 9 tails? So Anna Ferguson's tool here allows us to explore what to expect when chance is acting alone, and then it's probably better with an example. So the example I used, a very simple one, when I'm introducing binomial distributions to students. I like to give lollies out of my class, usually for hard work, but occasionally for participation. So what I did is I sent around a plate of lollies along with some dice. They got 7 dice. I did the maths at the supermarket so I didn't have to buy a second bag. And the number of 6s that they rolled when they rolled their 7 dice determined how many lollies they could have from the plate, and they just passed it around as they came in the class. And then at the end I got some data. Yes, I did once have 20 students in my stats class, but not this year. So there's 20 students there. That was the number of lollies that they said that they'd had from the packet. And then what we can do is we can take this data. So I just copy and paste the data in from text format into here. It's my sample data, and update it. Makes you a dot plot of the thing. And then over here, you're testing one of the theoretical models at the senior level. I noticed that binomial, I think in the draft, had dropped down to level 2, but then level 2 stats is no longer, I don't know. But binomial might have dropped down a little bit. So this is an example of 7 trials, 7 dice, a 1/6 chance of getting a 6, and then I generate 20 values because it's the same number of values that I had in my class, 20 students, simulate the data, and then it runs a simulation of classes of 20 students, and what you'd expect just by randomness, you don't expect it always to be the same, and then you can go over here, click the button, and it shows you whether the data that you observed in blue was believable, I guess. Could it have happened just by the binomial distribution? And so this is an example of where I believed the class. There was one class the year previous where at the 2 bar here, the 2 bar was like just above the cloud. And so over the whole period, I just carried on running simulations. I think her old version of this, you could run thousands and thousands of simulations just run in the background. And, at the end of the period, I still had 2 blue dots above the grey cloud, which showed me that I was confident there were 2 students that took more lollies than they should have. Yeah, catching the cheaters version too. So that's how I use the modelling tool. It's really a neat example of what variation looks like when you have a model. You don't expect the same every single time. Okay, number 2. My bad. Another distribution kind of question, which is a little bit more interesting than rolling dice and flipping coins. A few years ago now, my mum's small little TV blew up and she needed a new one. And so the first thing we do is go, okay, how big do you want? 32 is fine. Okay, cool. You can tell my battery was also flat on my phone at the time. $499, Sony or Panasonic. Don't really care, though. I think they're reputable brands. Same price. What do you notice different? $4.1 versus 4.6. One's based on 412 reviews, one's based on only 16. Which one do you trust? Do you go with the higher rating with the low reviews or the low rating with the high reviews? The inspiration for this actually came from a 3 blue 1 brown. So this is a bonus 3 blue 1 brown. Didn't make the list of top 10, but it's got some really, really cool stats videos in amongst all the calculus and stuff. And if you're interested in that YouTube video, do watch it. There's actually it's a 3-part series. Because it goes into look about, for this, suppose that 95% of customers were happy. The difficulty is you have to turn percentages into stars. But this example is a little bit easier. But if you had 10 reviews and 80% were happy, could the underlying experience be higher than that, but just they got a bad batch of 10 reviews, assuming the reviews are independent of each other? And not just the whole crowd going into a restaurant and all complaining. The 93% is based on 200 reviews. Could that have been lower? Could that have been 90%, but it just, by chance, in the 200 reviews, it got higher? So they explore that in the video, and you can also bring in the modelling tool to explore it if you want. Okay, number 2. Anyone seen this one? Oh, wow. It's amazing. It's called The Evolution of Trust. It's quite old now, but it's very topical given the political climate of the world and the unrest in certain nations and the potential war and all that sort of stuff. So it is very, very topical. I don't want to give anything away at this sec, but you could just, again, spend a whole period on this in class. The students love it. It's a really good example at a simulation, but not a simulation of how many cards can you collect where you have the full set. I know those are important and they serve a purpose, but this one here is a simulation where you can tweak so many variables. So it starts you off with a game where you're putting coins into a machine. Is this familiar now? So you can decide to either cheat or cooperate. If you cheat and the opponent cheats, bad luck. If you cheat and the opponent cooperates, you get more. If you decide to both cooperate, you get a little bit. And I'll just play just to show you. So if I go I'm going to cooperate. If I cooperate and the other person cooperates, we get nothing. If I cooperate and the other person cheats, they get 3 points, I lose 1. So it's kind of like real life when you're. So anyways. So I get a move. So I'm a nice guy. I'm giving out chocolates today. We both cooperated. So we got 2 points. Happy days. But, someday I just get a little bit ticked off and I'm in a bit of a grumpy mood and go, nah, I want more points. I want more than 2. I got 3, they lost 1. What's going to happen now? Should I cheat again? Because, cheating's just showing me it's good. Yeah, why not? Oh, they don't trust me anymore. All right. And so you can play this for a whole number of games. Then there's actually different people you can play against. So there's there's people that always cooperate with you. They're just nice guys and they always finish last. And there's people that are copycats, sometimes called tit for tat. Because if, you blow up something, I'll blow up yours, like that sort of thing. The really, really cool part is this, where you can simulate like a population of people of different types. So let's say if we go let's have a couple of nice guys in there, a couple of random who just make decisions on the fly like certain presidents, and then if you start, they play off against each other, and then you see who ends up winning in this. If there's enough nice guys in there, do they take over the world, or do the copycats end up taking over? You can change the money that you exchange each time. You can change some rules. There's also ability to put randomness in there, where it's like you go up going, I'm going to cheat, and then you accidentally forget your plan and you cooperate. So some randomness goes in there. But yeah, I'm not doing it justice. Go. Honestly, you could play that for like an hour, and even in your holidays, it's good fun. And it's got a little story to go along with it, and it relates it to things like in the trenches when they had a day where they stopped fighting, the truce. Okay, last one, number one. I feel like it needs a little bit of a drum roll, but this is an absolutely amazing website. Anyone not? I'll give you a hint. It's one of my favourite pastimes is cricket. The other one is enjoyment of food, clearly, and it's related to food. It's got a word that's kind of named after a type of food. Oh wow, you guys you're not going to get any holidaying, and this is awesome. It's called pudding. The pudding. Anyone heard of it? Yeah. Oh my gosh, it's amazing. So they have a whole bunch of articles that are data driven, visual sort of displays, but they're also interactive. And this deserves more than 3 minutes left I've got in my presentation, but I've put in a bunch of ones that I've used in class because whilst there are others, and the cool thing about it is you can Google music and it comes up with things to do with rap. Things like you can find something that your students are interested in, 100%. The birthday effect one in there, the birthday paradox I've mentioned already, but it's a different spin on it, where you can actually go and match other people who have entered their birth dates. But no, I really, really love this one, so I feel like it's a good place to finish. And it's probably the right audience to finish with. Oh. Don't know if you're about to hear this. Okay, I was born in, thanks Dave, the 1990s, 91. So it's going to play me a whole bunch of hits, and I've got to work out if I've heard them before. I got the RSA maybe one time. I'm going to say don't know it. I don't know. I haven't clicked the bottom one intentionally. Walk like a man. Yeah, so it shows you the data and basically it shows you where there's divides between millennials and all that. And I use this as a start of the year activity to get to know my students, to show them a little bit about my generation of music. Sorry guys. And then the cool thing is there was a follow-up to it where they explored the data further, and they showed that some music has retained its popularity over time, and other music has faded away. So Spice Girls and Wannabe still is recognised today for people that were born in the late 90s, early 2000s. Notice this is not a time series graph because the x-axis has been normalised so that you can the songs aren't necessarily released in the same year, but it's the number of years related to birth year. So it shows you some really neat stuff. Again, I'm all for like real interesting data visuals. It helps with my students studying towards scholarship stats. It's just cool stuff. So you can look at you can hover over here and go, oh, okay, Will Smith, Wow Wow. Now I know that song, but that's telling me that students that were born, nowadays they don't know the song at all. What do we know the song for? Maybe. Being terrible, or maybe the Men in Black. I don't know. So you find in here that some songs that have retained it because they're good songs. Some have retained it because they've been involved in what was the one from Stranger Things? Kate Bush running up the hill. So I personally had never heard that song, and now it's like one of my favourites.